Thank you for staying so late for my talk. We are peacemakers, not troublemakers. Peacemakers is a fabulous DRAM product company. Today, I'm going to introduce a new DRAM family for AI applications, which I think is better than HBM. We have a Samsung guy here. So, with the control. Oh. I'm sorry, this one? Yeah. How to do it?
The green button? Green arrow. Green.
Oh, green one, okay. Thank you. Now, this is, since last year, the large language model, there are different sizes of models produced. Different size, different model size require different memory to carry the parameters. But all of them requires high bandwidth. Now, this is the landscape of the current DRAM families. The low-power DDR, GDDR, and HBM. It's easy to see there is a hole on the upper left-hand side, which is we call high bandwidth, but lower density than HBM, because just mentioned there are various different model sizes which require different density, but they all need high bandwidth. Now, I'm sorry, I should introduce or explain the title. The title was HBM. The large language model in HBLL RAM. HBLL RAM, compared to HBM, there are 4 more characters. LL means low latency, and the RA is random access, which I think is better than HBM. Well, 2 more good characteristics. Now here, we need the lower density, high bandwidth. This one, the new family, we call the HBLL, in different generations. The current one we are in production is HBLL RAM, which is the low density, 0.5 gigabyte only, provide 128 gigabyte per second. And the one we are designing is the whole family using stacking. The bandwidth strategies are twofold. First, the vertical dimension, the data rate going up, and the horizontal one is the I/O width. The HBM going wide I/O first, then the frequency go up. The HBLL RAM doing the same, follow the same strategy. We have a 512 I/O, and later on 1K I/O. Then, in different generations, the frequency goes up. Now, we compare the HBLL RAM with the HBM with these 2 lines. The blue lines is HBLL RAM. The orange one is HBM. If we draw a vertical line, the same density of the array, the HBLL RAM can provide much higher bandwidth potentially. If we draw the horizontal line, the HBLL RAM can provide lower density than HBM. The reason why comes from this index, the bandwidth density, which is defined as the bandwidth, the maximum bandwidth can be provided with a unit density array. We say gigabyte per gigabyte. The different families shows up here. So the HBLL RAM is much higher than HBM, low power DDR, and GDDR families. So that's why we can provide that two difference. Now, the bandwidth, when we're talking about bandwidth, people are always talking about the sequential one. Now, this curve, the horizontal axis is the granularity of each random axis. On the right-hand side is more sequential. The left-hand side is more random axis. The HBM, if we compare to HBM sequential bandwidth is very good. But the random axis bandwidth is poor. So the HBLL RAM can do much better in the random axis. The red line compared to the green line. In terms of energy efficiency, the power consumption, since the HBLL RAM can provide the same bandwidth with the smaller array density, or we say the page size is much smaller, so the power consumption can be less. This architecture was published in 2017 in ISCC. Now this is the small density one. The single chip can provide 128 gigabyte per second bandwidth with 8 channel, and all the signal bumps are located on one side of the chip. The latency is about half of the traditional DRAM latency. It's a low latency. And the bandwidth of random access is higher than HBM. Now this is a simulation done by a CPU company with or without this HBLL RAM as level 4 cache. The result, on the right-hand side, the latency is 1/2 of the system without. And on the left-hand side, the figure shows the average bandwidth can go up when the system requires, instead of the blue line, which is flat because it cannot provide that much bandwidth. And the interface is simple. It's SRAM-like. So this state diagram, there's only 2 bubbles, read and write. And others are refresh and model reset. This is an article Jim Handy did. That big red arrow is our HBLL RAM, introduced between level 3 cache and DRAM. Now, this is the demo board. And this is one of our customers' board. It's ABF only, no CoWoS. Since the memory controller is so simple, so we provide it to our customer, the memory controller design and the PHY. Today, one of our customers is trying to use even the low-density HBLL RAM for the large language model. The 8 of them can provide 4 GB density for small language model. But the bandwidth is high. It's 1 TB per second. And the board is cheap, very low cost. And in the future, it will stack it up just as HBM. But we don't need CoWoS. It's 2D, not a 2.5D, which means lower cost. And it can provide up to 128 GB to 16 TB per second solution for the large language model. Thank you very much.